Hey, this is chapter 5.8 and 5.9. We're going to be covering graphs of polynomials. So this problem is from page 387, and the directions are to graph f of x equals 1/6 times the quantity x plus 3 times the quantity x minus 2 squared. So when first looking at this equation, we can see or recognize that we have x plus 3 and x minus 2 squared. These are both zeros of f, so we can plot -3, 0, and 2, 0. So I'll bring up a graph. So -3, 0, and 2, 0. Next, we'll use our table of x and y values. So we're going to plug in points between -2 and 3 on our x side. So we have -2, -1, 0, 1, and 3. For some reason, when the book uses this, they skip 2, so I will do that as well. But you can really use any x value to find a y value. So we plug this into this equation, and for our y values, we get 8/3, 3, 2, 2/3, and 1. So we can plot all of these points. So next, let's connect our points. And this is the graph of our polynomial. Next, let's cover local minimums and local maximums. So first, we need to define what a turning point is. And a turning point is just that. Anytime the graph turns and changes direction. So we have 1 turning point and 2 turning points here. But if we had a graph that was like this, we'd have more than 2 turning points, as you can see. So our local minimum is the y-coordinate of a turning point if the point is higher, or if the point is lower, than all the nearby points. So on this graph, our local minimum would be here. Our local maximum is the same thing, except is a y-coordinate of a turning point if the point is higher than all nearby points, therefore this. It may be saying, well, aren't these points all lower or all higher? But we have to remember we're using the turning point definition, so these are our local minimum and maximums. Chapter 5.9, Write Polynomial Functions and Models. So we're told to write a cubic function with the x-intercepts -4, 0, 1, 0, and 3, 0. So we're recognizing that -4, 0, 1, 0, and 3, 0 are all zeros of our equation, or our function. So we can write those as x plus 4, x minus 1, and x minus 3. And then we have a in front of all of these, which is our unknown, and f of x. So we're constructing bit by bit our function. So we need to solve for a by plugging in our known values for x and y. So the coordinates of our fourth point, which I actually forgot to write here, is 0, -6. So this is our fourth random point that is not a 0. So let's plug in -6 equals a, which is still our unknown, times 0 plus 4, 0 minus 1, and 0 minus 3. Anywhere there is an x, we're putting in our x value at 0. Anywhere there's a y is -6. So when we solve this, we get a equals -1/2. So our final answer is f of x equals -1/2 x plus 4, x minus 1, and x minus 3.